evaluating a polynomial function, this is nothing but plug and chug. Okay, so I'm evaluating this function when x is 3. So f of 3 is 2 times 3 to the 4th power minus 8 times 3 to the squared plus 5 times 3 minus 7. And what I've got here, this is 162 minus 72 plus 15 minus 7. So f of 3 equals 98. Okay, so those are just plug and chugs. All right, so this next part will be new. And I included what was in the book, and then I wrote this in my own words. Okay. You don't have to write this down unless you really want to. It is in your book. It says the end behavior of a function's graph is the behavior of the graph as x approaches positive infinity or negative infinity. For the graph of a polynomial function, the end behavior is determined by the function's degree and the sign of its leading coefficient. Again, what in the world are you talking about? Okay, and this may not even make sense either, but obviously I'm going to show you examples and it will make sense. Okay, in other words, what is y or f of x? What is it doing when the graph is moving all the way to the left, like out in no man's land? What is it doing? Is it going up? Is it going down? And same thing to the right. Is it going up? Is it going down? And then there's all that little squirrely stuff in the middle that we're really not concerned about, because polynomials, sometime or another, it's going to take off. One, up or down, and that's what we're talking about. The very, very ends of these. Okay, so for example, if I have a polynomial that is of odd degree, so this could be x, this could be x cubed, x to the 5th, etc. It's going to look something like this if the leading coefficient is positive, okay? So it's going to look something like this. What's in the middle, though, we're not really concerned about. We're concerned about the end pieces, okay? And I also think of it, if this were x, this is basically x cubed, but if this were x, it would be going like this, okay? It would just go, be going up in a positive direction. Okay, but the book has it written in this order, this first and then the x value next, but I like to flip them. So as x is going to positive infinity, what is happening to y? What's happening to the function? Well, it's also going to positive infinity. So x is going to positive infinity. As this is going to positive infinity, this is going to positive infinity. Okay? Same with this. As this is approaching negative infinity, f of x is approaching negative infinity. Okay? All right, next. Next we have, same thing. This is a polynomial of odd degree, but this is if the leading coefficient is negative. So it's very similar, but like I said before, if this were a line, it would be coming down like this. And we know that the slope of that line is negative, okay? So when we look here, let's look at the very ends of what's happening. So as x is going in a negative direction, as it's approaching negative infinity, what is happening to my function? Well, it's approaching positive infinity. So as this is going in a negative direction, this is going in a positive direction. Same thing with this one. As it's going in a positive direction, the function is going in a negative direction, okay? So as x approaches positive infinity, f of x is approaching negative infinity because the x value is, or the y value is going down. Okay, those are the hard ones. Okay, these are much easier. Now we're dealing with a degree, polynomials with degrees that are even. So we're talking x squared, x to the 4th, x to the 6th, etc. And they basically look like this. Now x squared is just a parabola, right? X to the 4th looks something more like this. And they, again, in here they get a little squirrely. But it's the very, very ends that we're talking about. So if we have positive, or if we have even exponents, they're of even degree, and they have positive leading coefficients, this is that whole smiley face and frowny face. So if they have positive leading coefficients, then we're positive when we smile. So this is kind of that smile. All right, so as x approaches negative infinity, f of x, or y, is going to approach positive infinity. And as x is approaching positive infinity, f of x is also approaching positive infinity. So we're all very positive here, right? So if it is an even degree, everything goes up. So you can probably guess what's next. Okay, if we have, this could also be another parabola, frowning. Okay, this is if our leading coefficient is negative. This is frowning. And so as x is approaching negative infinity, y, or f of x, is also going to negative infinity. And again, as we're going to positive infinity, it's going to negative infinity because it's, you know, it turns upside down. It's a frown. All right, so what I've done, I'm hoping that this helps. This I do want you to write down and maybe keep it close by, because I'm hoping that this will help you memorize these. Let me make sure I wrote down the right thing in my notes. Okay, so if we have our leading coefficient, if our leading coefficient is, we're going to have a little table here, positive, here's negative. This is the degree. If it is odd, or it's even. Okay, and let's look at the basic graphs of all of these. Again, the easy one is even. So this is going to be, for example, this would be like x squared. And it goes up, right? These go up. If the leading coefficient is negative, then it goes down, like this. Okay, if my degree is odd and it's positive, this could be like just the x. X to the first power is odd, so it can look like this. Now, if we have x cubed looks more like this, okay? But anyway, they're pointing the same direction, okay? Same thing with negative. If x is going in a negative direction, okay, the slope would be coming down like this. And same thing with the x cubed. It also comes down like this if these are negative. So write this down. I think that this would be really helpful for when you're doing your homework and things. So pause the video if you need to, and I have got to stop because I'm way over time. And we'll see you in the next video.